Hello. Today is October blah 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 October 3rd, um, and this is a talk about Whiteboard. Um, so I fixed everything that I wanted to do yesterday. I may have said I fixed it already, but I don't know, not really. So I figured out what to do. Um, it's kind of annoying to go back to this problem over and over again, but I finally solved it. So the issue is that I was using something called existential types, and so I found out that you can use these things, and what it is just a wrapper. So you have basically a data object wrapper, which contains something like foo, which is of a type, and then you can put something like a for all x, and then make x have a particular class constraint or multiple on it. So, whatever x constraint on x, and then whatever, you can make it x, or you can make it whatever you want. So I should say data. So the thing is, there's this weird thing in Haskell where if you have such a data item and you have a parameter for a function, it's called bar, and it takes a wrapper, and one thing you cannot do is you cannot return what's inside the wrapper. So let's say I wanted to return something like an x, or an x okay, can't actually do that. So the x constraint on f, let's say, or whatever, and I wanted to return, so this belongs inside here, return an f. So, I mean, obviously this doesn't make any sense at all, because f could be anything depending on what the caller chooses. So first of all, this doesn't make sense. The other thing is, just in principle, the other thing is that Haskell will reject it based on this idea of it's called like a Scala variable escaping its scope. So what happens is, if you try to take your argument and unwrap it, so you have the wrapper here, and we call this fv for f value, and we return f value here, it won't allow you to do that. This occurs even if you don't include any sort of type definition at all, which you don't need to do in Haskell. It just simply does not allow this. And I guess the reason is because x is not really a class, or not really a data type. It's a constraint on several other possible data types, so it doesn't really know what it is, and it just doesn't handle it. It just punts. So the alternative here, the other thing you can do is you can take a wrapper and you can work on it. So you can still do this part, and then as long as you just start messing with FE, like let's say that wrapper had a method on it called tree. So you could run tree on FE, and if that returned an int or something, then of course bar could, I'm not going to wrap the whole thing, but it can return an int, which it gets from this tree thing. So that's basically what you have to do. So it kind of makes everything kind of convoluted, and made me so, basically I had a read and write method, and before I was abstracting them out, so I had read and write, and they both called another general operation to handle most of the dirty work. But you can't do that with this, because all right, it's a little more complicated than that, but the read had one kind of wrapper called a QRead wrapper, and then the write had a QWrite wrapper. But anyway, this is getting really kind of down into the weeds, so I don't want to go too far in this, continue on the subject, so let's go on to other things. So after solving that problem, the first half of Whiteboard is finished, which is, or at least the design of it, which is the, what is it? It is the queues. It's basically the cat T part, where it's basically taking a bunch of data. Let me look at this. Hold on 1 second. I don't even. All right, whatever. See, now I'm just trying to review something I don't remember. All right. I don't see it here. oh right, it's an older version. I don't know. Okay, so basically what we have is this whiteboard's split up into two parts. Split up into tasks, and then it's split up into the database. And the tasks are basically the operations that need to occur to process the object. So it gets in an object, and then it does read and write operations on other objects. And then the DB is where it stores it. So it has, an least recently used memory cache, and it also has a file system, or a file back part of it, right? And so this is the part that I'm working on now. And so I have been looking at some things such as, let's see, well, first, one thing that we have is in the database we have key aliases. So every object can have multiple keys. So let's say you have key 1, key 2, key 3. They all point to the same object. So there's one rule here that I'm thinking of imposing. I think it'll work, is that from an object you can extract all the keys for it. All keys. And so this way you just get all the keys out. The DB consists of two things. It consists of basically, well, first of all, there's going to be like a kind of like a hard-coded key. Maybe I could call it not a root key, maybe a hard, maybe we'll call it default key or something, def key. So it consists of a def key and then a bunch of other keys. So under the def key, I'll explain about this a little bit more later. Under the def key there is chunks, and chunks are basically these little, it's just basically blocks of data encoded as files, and in each of these blocks is basically just a bunch of objects. And the point of them is because obviously you don't want to write one object to one file, one object to one file is really bad for performance. Instead, it's a lot better to write a whole block of data and then read that whole block. So you just read and write a bunch of keys at once. So this is what under the def key. So def key is basically going to be like a directory, or a directory tree actually. It's going to have a key type, and underneath that it's going to have, I think it's going to be a key hash. Not exactly sure here, but I think it's going to be a key hash of all the other keys. And then under that will be, or maybe this will be just the file name. But anyway, this will contain oh actually, you know what? Scratch that. This is going to be just this is going to be in its own directory. So there's going to be a directory called chunks. This is going to contain all these chunks of data, and then this is going to be a soft link. All right, and then every key of every object that's in the chunk becomes a soft link. And so then what happens is all the other keys as well, like there might be key 1, key 2 for the same object, they also are soft links into this chunk. And so the idea is that, let's see, oh man, this is a long time ago that I was doing this, but I think the idea is that the object, actually, I'm going to have to think about this a little bit more, but kind of the idea is that the object chunk can be kind of moved away, leaving dangling links. And by doing this, we can instantly tell if an object has been deleted, because if there's if the key points to a dangling link, then we know, okay, the object has been deleted, it doesn't exist anymore. So this prevents us from having to kind of cascade through the entire system. Like if an object does get deleted, which will happen very often, anytime something is redone, usually the old object will be deleted and replaced with a new one. Then in that case, we just simply take the chunk and move it away, and then all the key references for that object disappear. So, however, I have to think about this a little more. I think I have ways that this works, because I mean, of course, there are multiple objects that point to the same chunk, so I actually don't really remember what I did for this, but that was basically the idea that I came up with, and I don't know what I did for the idea for the problem that the chunk might have multiple objects. Anyway, we can move on from there. Then what we have is a regular LRU cache, and the cache is just going to, and LRU is least recently used, and the cache is just going to contain a bunch of keys, and they point to objects. And of course, some keys are going to point to the same object because an object can have multiple keys. And so it's just a standard LRU cache. Along with that is going to be like a dirty map, which will map anytime an object is written to. It will go into this dirty map here. And then that dirty map will, so basically when you look up a reference to an object, you check the LRU cache, and you also check the dirty map to see whether the object exists or not. And so that way you never get old data, which is very important for the system, because if we get old data, then the calculation becomes corrupt, which is bad. So the other thing I realized is we need a read queue, because we need a way to specify that we are going to need to read chunks. So read data, and so this is going to be a queue of chunks to read, basically. And it's a little tricky, because once you read a piece of data, you have to go back and notify all the objects that wanted it. There might be several ones that requested the same chunk. We want them to unfreeze as soon as possible. So both, we don't want them to, of course, reread it, which we can do by just checking the LRU cache again, but we also don't want them to just freeze while we start reading other data. So if one gets hit, then and these other guys wait. That's bad too. So we need to work on that, or I need to work on that. And all right, let's see. And then the other thing is upgrades. So the default key, the main purpose of it is for upgrades. So the thing is, with an upgrade, the client software that uses this product, it might want to make changes to how it handles part of the calculations. To do that, it will update some action functions. And the action functions are based on a key type. So based on the key type, it runs either action function 1, or 2, or 3, and so on and so on. So this might be key type, foo key type, or bar key type, etc. So if this action function gets updated to action function 1, period, we have to update all the foo key types, and I want to do that quickly. I mean, the database could have terabytes of data potentially, so I don't want it to have to go in and search through the entire database for everything with a foo key type. So that's why I have this default key, and that's why I have this directory system in general, is that you can search for, okay, I want only the foo key types, and then inside this directory is going to be all the objects with the foo key type. Right, and if the directory gets too large, of course, we can split it off based on the caches. So we can have 0. You have the start of the hash. Oops. We can have the start of the hash, and then the rest of the hash in another directory, and so forth. So we don't have to worry about. Because I know it's kind of strange that we're putting all these objects into this file or this directory, and it could grow so large that there can be problems with the file system. So we can just kind of further deepen them into the hierarchy, I guess you'd say, by just having these sub-hierarchies based on their hashes. So that's how upgrades happen, is that they just look for the key type that has changed, and then updates only that data. And that's also useful for being able to select multiple things. So like if you have many objects, if you put them all under the same, let's say each key, we'll call it like a unit, I guess. So each key is made of several different units, which turn into subdirectories. So if we start out with a unit that says like objects, and then, well, maybe not objects, it's kind of overloaded term, let's say cars, and then maybe model here, and then, I don't know, and then underneath that we have the individual cars with like their VIN number or something. You can just search based on the unit, which is car, or you can search in the car in a particular model or whatever. And then of course if you want, say, hey, I don't want to search by car, I want to search by color, or I don't want to search by model, I want to search by color, you just make an alternative key, which is car color. And this would be just another key for the same object. So yeah, that's what I got so far today. It's pretty complicated actually, and I don't know, I hope to start banging away on this for the next few days. I hope it goes faster than I'm thinking it will, but of course that never happens. But you never know. Alright, so that's about it. Okay, bye.